teach you about the laws of exponents.
The laws of exponents.
Yes.
Yes, sir. Right now they're currently teaching about it this year.
Wait, can you say again, Manahil? What did you say?
I said yes. We've recently covered this topic, and I think I need to practice this topic a bit more.
Yes, one thing for sure, it's one of the topics that you need to make sure that you master before you get to grade, not necessarily 9, you will still find them in grade 9, but most importantly, you need to make sure that before you get to grade 10, you've mastered everything that is to do with the laws of exponents, because as you continue with mathematics, you will be applying these laws in all the problems that you're going to come across. So what I'm going to do here is to make sure that step by step we go through this topic and we solve as many problems as possible until you're exposed to all the types of techniques that you need to apply in solving problems related to the laws of exponents. So maybe let's start with the first law, Manahil. So we mainly have 4 laws, but let's start with law number 1. Are you now able to see my screen?
Yes, sir.
Okay, then it's fine. Law number 1, this is where we will be multiplying powers of the same base. Okay, let me do that and then do that. Okay, maybe let's start here, Manahil, to say what is meant by a power. So in mathematics, when we talk about a power, we talk about something that has a base and an exponent. This thing is called a power, with that letter B, which stands for the base, and then that stands for exponent. So law number 1, we will be multiplying powers of the same base. So that means it will be these things having the same base. So very quickly, let me write down the law itself, which says a, let's say, to the exponent of m. When you multiply it with a to the exponent of n, this should be equals to, you see now we have the same bases being a and a. So you represent it as one base. What do you do to the exponents? You add. Did you want to say something there, Manahil?
No, thanks, sir.
Okay. So this is what the law says. So any questions from your side up to this point, Manahil, or are we together up to this point?
I'm good, sir.
100%. So I'm going to now do some examples of which when I'm done, I will give you an opportunity to do some exercises and we will have a look as to what your final answer is. So maybe let's say example A, you are given x multiplied by, maybe let's make it x squared be multiplied by x to the exponent of 3. So when we apply law 1, Manahil, all that you need to know is that you've got two powers which are multiplying each other. So this is a power, Manahil, because it has a base and an exponent. This is a power because it has a base and an exponent. So the question now is, are the bases the same? Yes, they are the same because it's x and x. So you represent it as one base. What you do to the exponents, you add their exponents, which means finally the answer is x to the exponent of 5. Are we clear there, Manahil?
Yes, sir.
Okay, so now let's look at another example. Which one should I do, Manahil? Maybe let me do this one. I was just trying to check if... Okay, let's quickly have a look at this one, Manahil, because there is something very much important that you should be aware of on this one. So before we can do much, we need to firstly sort out this part which has the brackets. I'm only realizing it now, Manahil, that I shouldn't actually have taken you through this one because it includes another law which we will still have to look into. I'm just curious to know why it was included under law 1, but it's fine. Let's do it anyway. So, Manahil, do you agree with me to say a squared means 2 of exactly the same thing? If it was 3, it would mean 3 of exactly the same thing, which means we are having x multiplying negative x and again negative x. I'm not sure if I'm losing you there, Manahel.
Yes, sir.
We're still together, ne?
Yes.
Yeah, so now, do you agree that negative and a negative will become positive?
Yes, sir.
Yeah, so that means they cancel, and then we have x multiplying x multiplying x. So remember, we have invisible 1, invisible 1, invisible 1. So that means we are having 3 powers of the same base, meaning we represent it by one base and then we have their exponents being added together. So now it ends up being x to the exponent of 3. Are you okay on that one, Manahil?
Yes, sir.
Okay, then it's fine. Let's have a look at this one where we have a that is being multiplied by a b that is being multiplied by a, let's say squared, that is being multiplied by b to the exponent of 3. So I'm going to give you an advice, Manahil, and trust me, if you always work out these things this way, you will never go wrong, Manahil. Even when I have to look at what you've done, it's going to be very much easier for me to notice what went wrong and how to correct it. So at all the times, Manahil, before you can apply the law, try to group them together. You see, that one of base A, group it with that one of base A. And then this one of base B, group it together with that one of base B. So that means you've got A which is going to be put closer together to that one of a squared. Now you have that b, let's put it closer together to that one. So that means you obviously have invisible 1. Then you've got a, then you've got your 1 that you plus it with your 2, and then you've got your b, where you have 1 that you plus it with 3. And then finally, you have a to the exponent 3, b to the exponent 4. It ends there, Manahil, because you cannot work out a and b because they are not of the same basis. I'm not sure. Are we together there, Manahil?
Yes, sir.
Are you sure?
Yes, sure, sir.
Okay. Let's have a look at the last example, and then from there, I'm going to give you some problems to work out. Okay, let's say we have 2 to the exponent 4 multiplying x multiplying, let's say 3 to the exponent 5 multiplying, let's say y to the exponent 5, let's say multiplying 2 to the exponent 3, multiplying x to the exponent 5, multiplying y squared. I'm going to give you that advice again, Manahil, where you need to group them. So in this case, wait, are you saying something there, Manahil?
Sorry, sir?
Did you say something?
No, I was gonna ask if we were if I should work it out and then tell you the answer.
Oh, okay, then it's fine. So maybe let me very quickly sort it out and say the best way to go about it is to start by the numbers followed by the letters in alphabetical order, meaning we will have 2 to the exponent 4, let's group it with again 2 to the 3, and then the other number is this one having a base of 3, and then we now have x to the invisible 1, let's group it with that x to the 5, and then followed by y to the 5, let's group it with y to the 2. Are we together there, Manahil?
Yes, sir.
Okay, then it's fine. We end up having 2 to the 4 that you plus it by 3. This one of 3, it doesn't have another base to work it with. And then here we end up having 1 that you plus it by 5. Have y that you plus it by that. And then we end up having 2 to the 7. 3 to the 5, x to the 6, y to the 7. This should be the end of it because what we are mainly interested in, it is the application of the law. So let's see, any questions on that one, Hill, or are you ready to start working on some problems?
I'm good, sir. I'm good to solve problems.
Okay, then it's fine. Maybe let me quickly check something here. I'll just take a few of them, and then from there, and let's see. No, and not that one. Okay, it's fine. I'll give you this one, Manahil. Yeah, I've got a lot of problems to choose from, Manahil, and I'm not really sure in terms of which one I can. Okay, it's fine. Let me give you this one. 3 to the 6, 5 to the 8. And then the other one, maybe let me give you this one. This one is 6. Yes, can you see those two problems, Manahil, A and B? Manahil, are you still there?
Yes, sir, I'm still here.
Yes. Are you working on them?
Yes.
Okay, then it's fine. So just like we do, Manahil, you work on them and then you take the photos and you send to me via WhatsApp inbox. So only send once you've worked on both of them. Then I will check what you've done on both of them. Manahil, are you still working on them?
Yes, sir. I'm on the last one.
Okay, then it's fine. I'll just be waiting for the photos. As soon as you are done, you can just take those photos and then send to me via WhatsApp inbox. Okay, let's see what you've done. Okay, photo for problem B came through. So you okay. Maybe let's start with that first one and see. So we have 5 to the 7, 3 to the that, 3 to the that, 5 to the that, yes. Grouping them together, that and that, that and that, yes, that and that, that and that, that, yes. Yes, is correct. And then we have that, to the that and that, yes. 2 times 6 is 12, yes. And then we have x, that to the that, yes. That to the that, yes. That is 100% correct. Manahil, exactly how you should write them, honorable members. So now we are going to move on. So with us moving on, Manahil, I want to introduce law number 2. So law number 2, this is when we are dividing powers of the same base. Dividing powers of the same base. Okay, then it's fine. This is how the law works. Let's say we've got a being the base to the exponent of m divided by another a to the exponent of n. So because we are dividing powers of the same base, we represent it as one base, but we subtract the exponents. Maybe very quickly, Manahil, let me give some examples that we can work on, and then from there we will see if you understand. So example A, let's say we have 2 to the exponent of 8 divided by 2 to the exponent of 3. So this one, Manahil, because the bases are the same, we represent it as 2 being one base, and then we say 8 minus 3. It ends up being base to the exponent of 5. I'm not sure if I've lost you there, Manahil. Are we okay on that one?
Yes, sir. I understood.
Okay, then it's fine. So now let's have a look at this one being x to the exponent of 8 over x squared. So that means this one, we are definitely going to have the same base being x, and then we have our exponent minusing there, meaning we end up having x to the exponent of 6. That also, Manahil, we are okay on that one, isn't it?
Yes, sir.
Yes. So this is what I usually say, Manahil. If, maybe let's consider this to be example C. If we have, let's say, y to the exponent of 3 divided by y to the exponent of, maybe let's say 5. I always say we must say the base with the bigger exponent minus that of the smaller exponent. So what I mean by this, Manahil, is that here we have invisible 1, which will remain there, so that we will say y at the bottom, because it has a bigger exponent, then we will take this one and minus it at the denominator, meaning we have 1 over y to the exponent of 2. Did I lose you there, Manahil?
No, sir.
Maybe let's say we have example D there. Maybe it was negative 3 x to the 2 over, let's say, x to the 4. So that means this one, that negative 3, it is the coefficient that will always remain as the numerator. But where you now apply the law, that will therefore minus that, and you end up having negative 3 over x to the exponent of 2. I'm not sure if I'm losing you there, Manahil. Maybe let me give the last example and say if we have x, y, let's say squared there, and then here we have y, maybe let's say 4 there, and then we have x to the 5. Yes. So this one, Manahil, what I would do, it is to therefore say y 4 minus 1, because you have invisible 1 there, and the bigger exponent is the one at the top. Then the bigger exponent for the x, it's at the bottom, then I will subtract them there. Meaning we end up having y to the 3 over x to the 3. Did you understand, Manahil?
Yes, sir.
100%. So now I'm going to give you some examples to work on, and then from there I'll be knowing if you understood or not. Which one am I going to give you, Manahil? On my examples, maybe let me give you these, so you can now start working on them, Manahil. Part B, I will give you x squared over x to the 8, then we'll give you d being x to the 4 y squared over x y to the 3. Should I give the last one? Yes. Negative 6x to the 3 y squared all over negative 2x y to the 3. Yes, Can you see those exercises, Manahil?
Yes, sir.
Yes, very quickly work on them. As soon as you're done, you take the photos just like you did, and then you send it to me via WhatsApp inbox. Then I'm going to check, and I will take it from there. So I'll be waiting. Manahil, as soon as you're done, take those photos, send, and let me know. Okay, and let's see. Uh, okay. Okay. I see what you've done. Let's maybe start with the first one, here. So you see on that first one, just so that is clear, I'll rewrite what you did. So you said equals 2 to the exponent 8 minus 3, and then you said to the exponent 5. So there's a mistake there, Manahil. You know where the mistake is, Manahil?
No, sir.
So you firstly need to check and say, are you taking the exponent of the numerator to the exponent of the denominator, or are you taking the exponent of the denominator to the exponent of the numerator? Am I not confusing you there, Manahil?
No, sir.
So what I'm saying is, can you see you are taking that exponent of the numerator to the exponent of the denominator? So when you do that, something has to remain in the numerator, which is 1. It will always be invisible 1 if there's something there. So that means, Manahil, you will have 1 over 2 to the exponent 8 minus 3, which is the same as 1 over 2 to the exponent 5. Does it make sense, Manahil?
Yes, sir.
Yes, so that one is different from when you have 2 to the exponent of 8 over 2 to the exponent of 3. In this case, that's when you take the exponent there, you take it to the top. When you take it to the top, it becomes 2 to the exponent 8 minus 3, which is 2 to the exponent 5. So what you've done there, you worked it out as if this is the problem that you were given. Do you now notice your mistake on that one, Manahil?
Yes, sir.
Yes, that means even on that second one, maybe quickly redo that one because you've done it the same way, where your final answer is x to the 6. Do you want to rewrite it, or you are able to tell what the answer should be?
I can rewrite it, sir.
Okay, it's fine. Very quickly, you can rewrite it and then send it to me via WhatsApp inbox. Name.
Yes, sir.
Okay. Okay, Manahil, redo D. Even that D, you will need to redo that one.
Yes, sir.
Yes, and then when it comes to that one, we will look into that. But for now, I'll redo those two.
Sir, must I also do E?
Your E is wrong. Did you notice that it's wrong and you want to redo it?
Yes, sir.
Yes, that is wrong. And yes, you can redo it. You can also include E. Maybe let me give you a tip there, Manahil. You say, this, you just do it the normal way. You don't apply the loss of exponents for those two. It's like that cancels with that, and then it's like 6 divided by 2, it gives whatever that it gives you. Then when it comes to the loss, you apply them on these ones that have the base and exponent. Does it make sense, Manahil?
Yes, sir.
Yes, as you work it out, take into consideration all of that. Okay, let's see. Okay, let's see there, that and that. Okay, I see what's confusing you, Manahil, but we will have to redo it. That, and now that one is correct. That, and that. Okay. I can see what's confusing you, Manahil. Maybe let's redo it this way. I'll just have to remove all of that. Then we'll redo it together. I can see what's confusing you, Manahil. I'm just trying to think of the other way in which I can explain it. Just so that you then master how to do it. Okay, so maybe let's redo all of them, Manahil, to say between the exponent for the numerator and denominator, which exponent is bigger?
The 8.
Yes, so that means we will need to take that exponent to the bottom. Do you agree?
Yes, sir.
Yes, then at the top, 1 is going to remain. So that means we have 1 over 2 to the exponent 8, then we will minus 3. And then the answer will be 1, 2 to the exponent of 5. This one, it is the end of it. So now let's get to B. When it comes to B, Manahil, do you agree that we are still going to do the same, taking that exponent to the bottom?
Yes, sir.
Yes. So that means invisible 1, it is the one that is going to remain at the top because you are taking that exponent to the bottom. So that means you end up having 1 over x to the exponent 8 minus that, it gives you 6. Do you agree there, Manahil?
Yes, sir.
Yes. So now let's get to this one. So how this one works, it's like it's a mix. Others go up, others go down. So there you have invisible 1. I'm hoping we did not lose. Oh, no. No, 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 no. I don't know why, Manahil. I do not know why. But all of that information disappeared. Let me do this. I will therefore have to go back to that information and rewrite it. Luckily, this lesson is recording. So that means all that we did is on record. But I now need... Wait, where are those problems that I gave you, Manahil? Okay, let me check via WhatsApp inbox. D, I think this is the last one. Okay, Manahil, this is the one that I think is. It is this one. It is this one of x to the 4. This is the one that I was about to do, Manahil. Yes, I think it's this one. Manahil, are you still there?
Yes, sir.
Yeah, so here I was saying we have invisible 1 there, we have invisible 1 there. So this one, because it has a bigger exponent, it means this one will go work it out at the top. And then this one will have to come to the bottom. I'm not sure if you understand there, Manahil.
Yes, sir.
Yeah, so that means how you should work it out. It is to say at the top you have x to the exponent 4, you minus 1. And then at the bottom, that's where you have a bigger exponent. So that means you will minus at the bottom. So that means you have x to the exponent of 3 over y to the exponent of 2. That is the end of it. Does it make sense, Manahil?
Yes, sir.
Okay, then it's fine. Let's now have a look at this other one, which is negative 6 x to the 3 y squared all over negative 2 x y to the 3. Okay, so now let's see, Manahil. Negative will cancel with negative. Do you agree?
Yes, sir.
And then what is 6 divided by 2?
3.
That means we have 3. And then it looks like this x will go to the top because it has invisible 1 which is smaller than that. Do you agree? It's like we want to say bigger exponent minus smaller exponent.
Yes,
Does it
sir.
make sense, Manahil?
Yes, sir.
Yeah, so that means we have x, big exponent minus small 1 over, this one will come to the bottom because y to the 3 is a bigger exponent minus that one. So we end up having 3x to the 2 over y to the invisible 1. That is the end of it. So can you see your mistake, Manahil? Does it now make sense?
Yes, sir.
Okay, very quickly, let me give you this one until I'm satisfied. I'll just create my own and say x, y, over x squared 1 and, and 2 and yeah. Okay, let's say that. Okay, Manahil, very quickly, can you work on those two?
Yes, sir.
Okay. Okay, let's see. Okay, number one. Love that. Love that. 100%. And that over that is negative 2, yes. And that. That. Okay. Okay, so Manahil, let's have a look at that second one. So the first one, you did do it correctly, but this one, yes, negative 4 divided by 2, it is negative 2. But can you see, Manahil, when it comes to this, looking at that, the big exponents are at the bottom, both are at the bottom. So that means you will say over, then you have n squared to minus 1. You have m squared minus 1. Then it means you have negative 2 over n to the 1, m to the 1, which are invisible 1. I'm not sure if it makes sense, Manahil.
Yes, sir.
Did you notice your mistake?
Yes, sir.
Okay, 100%. So it's fine. We can end it here. So what I'm going to do as soon as the lesson is done, I will send you some exercises that you need to work on until, let's say, you will submit before our next lesson. Did you hear me on that one, Manahil?
Yes, sir.
Okay, 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 okay. Then it's fine. Let me quickly check something. Combining that and that. And let's see. Let's see, Manahil. Okay. No, it's fine. The next lesson, we will then expand on what we have covered. But for now, I will just give you some problems to work on, which will be related to what we have covered in today's lesson. Okay, then it's fine, Manahil, until we meet again on our next lesson.
Yes, sir.
Okay, have a very good night. Share device audio. Okay, then it's fine, Manahil.